Okay, so it's the second week of Context for Learning. In the first week, you spent some time introducing context for learning, and then you spent 3 days on what I'm going to call the rounding investigation, right? When you go into the next week, that's the week we're talking about now, you're going to do another round of the rounding investigation, and then you start T-shirt factory proper, which is the T-shirt factory in this book, right? You start this where you're looking at tens and ones. So I want to make sure that, first of all, we really understand what the first week of rounding and the second week of rounding have to do with each other. And then we can kind of get into this new investigation here. The first thing is to notice is that second round part of rounding wraps up right when we're beginning rounding in my math, right? Round two-digit numbers. And so as you're doing both of these, the one from the first week and the second week, you should go into it knowing, right, that the kids are going to eventually learn a rounding algorithm. Like when you teach this in My Math, I encourage you, watch the My Math video, like now. But when you teach this in My Math, you're going to teach them. Like if I'm trying to write what sizes miles is between, you're going to teach them 41, think of 40 and 50, think of the halfway mark. 41's less than 45, so it must be closer to 40. Like we have a whole chicken analogy, and we eventually get it down to an algorithm, right? Like step 1, think of what it's between. Step 2, use the halfway mark. Step 3, what is it closest to? So they're going to get there. Like you're going to tell them. So what are all the skills? Like if rounding algorithm is one part of the landscape, right? How are we using these two investigations to get all the other pieces that come before that, knowing you'll get there eventually, right? So, like, what's useful is to think about what kids might do wrong, because that, even if you think of it as wrong, is still somewhere on the landscape, right? So, for example, you're going to have a bunch of kids who are just like, this is closer to 40. This is closer to 20. This is closer to 10. This is closer to 20. This is closer to 20. This is closer to 3. Right? And so one part of the learning landscape is just understanding, like, what does it mean to say that something is close? Right? Like an understanding of close, as in 41 is 1 away from 30, that's a pretty big idea to understand before you can say, okay, so 40 is helping me figure that, 45 is helping me figure that out, right? Another big idea that's going to come up is this word between. Because if I'm thinking about 41, right, and what it's close to, I need to know that I'm not just comparing it to 40, I'm comparing it to 50. And actually, I went over these in the wrong order. Like this actually probably in the landscape comes before this. Like closer only matters if you have two things to kind of be closer to. So if all you're getting out of these units is this idea of 41's between 40 and 50, that's still an amazing thing to get out of the unit. It gets you one huge step toward this algorithm. Then thinking about close. And when you get to rounding, you could be thinking about a rule. You could start to say, okay, we know 41 is between 40 and 50. Now what's this closer to? Now I mention this because I'm hoping on the first week you can have this conversation about between and close so that when you do it again the following week, okay, now I have some adult sizes. Help me with these adults. The question I really want you to focus on is there some rule that could help us anytime we want to choose a size? Right? So eventually, like, I might need to go through when I'm first doing this and actually I'm using a number line and I'm really thinking, okay, I could choose 80 or I could choose 90, Let me think about the in-between. Is there a rule? Right? 82. And one of the things that's going to come up, specifically the second time you do this, is that you actually can't say about Bella and Matthew what it's closest to because they're right in the middle. And so you might have a rule that if it's 1, 2, 3, or 4, that it's closer to the lower size. And if it's 6, 7, 8, or 9, it's closer to the higher size in the ones place. And you're going to have to kind of agree out of this thing that 85 and 75 are really tough because this is equally far away. And going back to that landscape of learning, by the way, even far, how far, is a concept that I'm not sure our kids have. That is on that landscape of learning, understanding distance, like the 82 is 2 away from 80. Right? And that it's 8 away from 90. So I mention all that because you're doing this investigation, what will feel like a second time, the same thing. It's not because you're trying to drill and kill. It's because the landscape is actually harder and more complicated with more deeper understandings than we might have thought, and I want you to spend your time there. You get Monday, Tuesday, and Wednesday to work on that. There's a number string that's a part of it. And then when you're done with that, you start day 1. You read more of your story. And when you get here, some really nice stuff happens where we're starting to think about tens and ones. Nicholas is trying to keep track of his loose and his rolls. And you're going to say, let's stop and think. Did Nicholas record the right numbers in his cheat chart? Here's what is really important about this. I've been working with various kids over the summer, and I might say to a kid, how do I model 43? Or like, how many tens and ones are in 43? And when I watch a kid do it, what I watch them do oftentimes is say 10, 20, 30, 40, 41, 42, 43. They are still counting, right, to figure out tens and ones. We'd eventually like them to instead use place value to know tens and ones. To say, without needing to count or model, 43, that's 4 tens and 3 ones. 1, 2, 3, 4, 1, 2, 3. So that's what's happening here. You're going to have, in this investigation, teachers, because they've seen kids just draw 43 and get quote-unquote a right answer, think kids are farther along the landscape than they really are. But the fact that I see so many kids still starting back at counting 10, 20, 30, 40 leads me to believe they haven't yet learned a shortcut, really internalized it. So that's what we're doing on this day. Did Nicholas record the right numbers in his teacher? You have a conversation without pointing out the pattern. Let the kids tell you. And then you're going to check some numbers. Like, how many rolls then could be made with the 43 t-shirts? You're kind of saying, oh, he's saying 4 rolls, 3 loose, with 18 t-shirts, with 39. So you're quick doing a little bit of probing and digging for the understanding, and then you set them loose. Now, in your booklet here, it suggests that you use cards. So it's, day 1. In the developing the context, here they say, explain that you've prepared some cards and hand them out. I think that the cards have really stressed people out in the past, partly because the kids all get different numbers. And I think that just really stresses people out, and never mind that you have all these cards floating around. And so I've just given you some numbers. Like, instead of being like, here, every group has different numbers, tell me how many rolls and how many loose, I've given you some numbers. Let's pretend we have a t-shirt factory like Nicholas. Imagine you got some inventory, right? You have some smalls, you have some mediums, you have some larges, you have some extra larges. This isn't the inches, this is how many t-shirts you have, right? I need your help knowing how many rolls and how many loose we have. And then you just set them at it. And pay attention. Like, your job is not to grow kids at this point. Your job is to learn about kids. Like, who has to actually count out 2 10s and 8 1s? Maybe then you point them towards their neighbor who's getting it faster. Different way. Who starts to draw 28? Like, I know kids who, if you gave them manipulatives and were like, well, let's lay out 28, they'd start counting out 28 individual cubes. They know this has 2 10s and 8 1s if like their teacher asks a math class, but that's not still their default, right? Who just gets it, puts it in the chart, but then is thinking of it as 10s and 1s, but can't really say, like, if you say, well, how many rolls, they're not thinking of the 10s as rolls. They can't really say it. Yeah, and then this is where the real magic happens. How many rolls are in 123? And there aren't just 2 rolls. So we say this number 123, right? But there are going to be 12 rolls. And ideally, in like the perfect world, there's no gallery walk, by the way, this day. There's no poster making. When you share, you might have a kid say, I can see that there are 12 rolls because I just look in the tens place and bigger. Like, I can set up all my numbers to say rolls, loose, rolls, loose, rolls, loose. So guess what? Rolls, loose. And then you can have a big conversation like, are you saying 100 has rolls inside of it? How many rolls are inside of 100? How come 123 has 12 rolls? Let's try some other numbers. Like, do you think this works for 139? Do you think it works for 248? Like, can you always just look here in this place and get the number of loose? Like, why is that it works? That's a huge idea, right? That really goes beyond, like, I have to draw this. Like, if I'm trying to see how many 10s are 139, I better count and figure it out. To, like, I'm now using, like, in what in some ways is a trick. And can I explain why it works? So that's that goal on that Thursday and Friday. You introduce this is the task, they work, and the next day they can wrap up the work and have a math congress and hopefully start to delve into, right, the fact that this tells me the 10s, the fact that this tells me the 1s, or loose and rolls, or rolls and loose, and that this also has lots of rolls inside. It's gonna be fun.